By using the principle of mathematical induction, we need to show that the inequality n is less than 2 raised to the power of n. This is a true statement for all n belonging to the set of natural numbers. Okay, let us begin. So here, first we are going to consider the statement p of n. So let p of n be the statement such that we have n is less than 2 raised to the power of n. Fine. So we'll have to show that this particular statement is true for any natural number that we pick up. So let us begin by considering the first natural number 1. So for n equals to 1, we get the statement p of 1 such that we have 1 is less than 2 raised to the power of 1. And we know that's a true statement. 1 is definitely less than 2. So this means that our statement p of 1 is true. However, we'll also need to verify that this is true for other natural numbers as well. So what we'll do here, we will assume that p of m, so let's say p of m is a true statement. If p of m is a true statement, this means that p of m, the statement p of m will be given as m is less than 2 raised to the power of m. Okay, let's label this as number 1. Now using this, we'll have to show that the statement p of m plus 1 is also true. Now what is the statement p of m plus 1? Let's try to understand that. So p of m plus 1, that statement states that m plus 1, all we have to do is replace this m in the statement number 1 with m plus 1. M plus 1 has to be less than 2 raised to the power of m plus 1. So we'll have to verify that this is true. If this is a true statement, then we'll be able to say that Pn is a true statement as well. So how shall we do that? Okay, fine. So here we will use number 1, statement number 1. So from statement number 1, what we have here is m is less than 2 raised to the power of m. So let's do one thing. Let's multiply both sides with 2. 2 being a positive number, that's not going to change the inequality symbol here. So we have 2 times m. So that's going to be less than 2 multiplied to 2 raised to the power of m. Now 2 times m, that can be also written as m added to m. So this is going to be less than, now 2 multiplied to 2 raised to the power of m, that's simply 2 raised to the power of m plus 1. Okay, fine. Now, in reality, we have to show that this inequality is true. That means 2 raised to the power of m plus 1 is greater than m plus 1. However, what we are getting here, 2 raised to the power of m plus 1 is greater than m plus m. However, we know for a fact that m here is nothing but a natural number. Now, since m is a natural number, we can always say that this value of m is going to be greater than 1, or at least it's going to be equal to 1. That's the lowest value of natural number that m can possess. So m is going to be greater than or equals to 1. It can start from 1 and it can take the other natural numbers 2, 3, 4, etc. Now what we'll do, we're going to add m to both sides. So we have m plus 1 less than m plus m. So here we have obtained that m plus m, that's greater than m plus 1. So now let's call this number 2 and let's call this number 3. So if we combine 2 and 3, so from 2 and 3, what do we get? From 2 and 3, what we obtain here is that we have m plus 1. So this is going to be less than m plus m. And we have already seen that m plus m is going to be less than 2 raised to the power of m plus n. So if we combine this, or we can, in other words, we can always say that m plus 1, this is also going to be less than 2 raised to the power of m plus 1. And this is exactly what we had to show. So that means we were successful in showing that m plus 1 is less than 2 raised to the power of m plus 1. In other words, what we have shown here is that the statement p of m plus 1 is true. So if p of m plus 1 is true, now we can generalize. We can generalize everything and say the original statement p of n, this is going to be a true statement by the principle of mathematical induction, and it is going to be true for all n value belonging to the set of natural numbers. That means any natural number that we pick up, the statement n is less than 2 raised to the power of n. So this is always going to be a true statement. We can verify that if we consider n to be equals to, let's say, 4, then 4 is definitely less than 2 raised to the power of 4. Fine. It's always going to be true for all natural numbers, hence proved.